So now we can see how we can model data in real world situations. So the first example is on bacteria. It says a bacterial culture starts with 1,000 bacteria and doubles in size every 3 hours. Find the exponential model for the size of the culture as a function of time t and hours, and use the model to predict how many bacteria there will be after 2 days. So remember, when a problem asks for a model, they're really asking for an equation. That's just another word for model. They also tell us that this is exponential. So that means that we're going to need to be working with an exponential function. Sometimes they want a linear function, a quadratic function. In this case, they want exponential. And so the previous examples that we were looking at, they all required us to have some values. So for example, in order to do these equations here, we always needed some points. So notice here, I at least had 2 points. So in this problem, they don't give me that information. So we need to get it from what is already written in the problem. So whenever you start something, we're starting with time 0. And at time 0, you start off with 1,000 bacteria. So you notice here, my 0 is going to be the time. And the 1,000 is how much bacteria I have. So then it says that it's going to double in size every 3 hours. So at time 3, this is going to double. So instead of 1,000, it's now going to be 2,000. So we can follow the procedure now since we have 2 points. And you're going to notice that this value 1,000 is actually already the value for A, because notice that x is equal to 0, so that makes this the y-intercept. But if you're not sure or you want to follow the process, then we can do that as well. So y is 1,000, and then x is 0, y is 2,000, and x is 3. So if I divide, then we're going to have 2 is equal to b cubed. Take the cube root. So we end up with b is equal to 1.26. Now we need to find a, so we can substitute it back. I'm going to go ahead and use this one here. B is 1.26. Remember that anything to the 0 power is always going to be 1. So A is 1,000. So again, from the beginning, this is already going to be A since you have x equals 0, so that's your y-intercept. So your model or your equation is y equals A times B to the x power. Once we have a model, then we can predict how much bacteria there will be after 2 days. So it's important here to know that your time is in hours. So note it says 3 hours. So this is hours. And the reason it's important is because now they want us to predict after 2 days. Well, how many hours is in 2 days? So that's going to be 48 hours. And so now I can use my model and substitute that information. So for x, I'm going to put 48. And so in the calculator, we would type in 1.26 raised to the 48th power times 1,000, and this will become the following. So this is how much bacteria you would have in 2 days. Okay, let's look at example 15, aspirin. After taking an aspirin, a patient has observed 300 milligrams of the drug. If the amount of aspirin in the bloodstream decays exponentially, with half being removed every 2 hours, find the amount of aspirin after 5 hours. So again, we need to have 2 points. So my first point will be 0 and 300, because that's what I began with. And then it tells us that the aspirin decays exponentially with half being removed every 2 hours. So after 2 hours, we're only going to have half of the 300, which is 150. Again, I always like to make a note of what my x is, the unit for x, which is hours in this case. I'm going to also say that this is already a because that's my y-intercept. And so really, I can just plug that information. So here, I'm going to use my second point. Y is 150. A is 300. We don't know what B is, and X is 2. So if I divide by 300, I get B squared is equal to a half. Take the square root. So B is going to be equal to 0.7071. So my model is going to be Y equals A times 0.7071. Notice that since this is decaying, that's why we end up with a decimal here. So it says find the amount of aspirin after 5 hours. So it's asking for 5 hours. My units are hours, so I can just plug in the 5 for X. And so that's going to become 53.03. Since you're working with a word problem, then it's always nice to write a sentence. So after 5 hours, there is 53.03 milligrams of aspirin left in the bloodstream.